In this video, we are going to see how to find the maximum cut of a graph using coupled oscillators. The objective is to find a subset of vertices S such that the number of edges between S and its complementary S bar is maximum. Max cut is an NP-hard problem, and finding an optimal solution requires exponential time. By mapping vertices to oscillators and edges to capacitors, ONN can solve the max cut problem. We use subharmonic injection locking to obtain binary phases and to anneal the system to escape local energy minima and find an optimal solution. We use our ONN on PCB as a proof of concept to solve the max cut problem. We have 9-off-the-shelf relaxation oscillators that implement vertices of a graph. Then we define edges using coupling capacitors and an FPGA to initialize and read the final phases. Finally, the FPGA commands LEDs to visualize in real time the max cut solutions. Now, let's take a closer look to the experimental setup. We inject an harmonic signal to the oscillators at twice the oscillating frequency to ensure binary phase locking. We ramp up the amplitude as annealing to escape local minima and find good solution. Here we can see the 4 analog waveforms. The injection starts slowly and increases just before measuring the phases. Here a new computation occurs. Then we can check the results in real time by looking at the LEDs and by comparing with the graph. Here is another simple example with 9 oscillators. Again, the annealing procedure starts and we can finally measure the phases. We repeat the process so we can visualize in real time several computations. We add few edges to the previous graph and we observe that the ONN converges toward the optimal solution every time. We complexify a bit the graph by adding 2 more edges. We see that the ONN finds a good cut solution of 10. Interestingly, it sometimes finds another solution, such as this one of cut 10. However, a better solution exists and is given by the following configuration. In this video, we have not varied the oscillator initialization time, and we believe it limits the number of possible solutions. Next step will be to apply a uniform distribution on the initialization and statistically assess the quality of ONN solutions.